All right, we are live. So, hi, I'm Rajesh Kasirangan, one of the co-founders of ClimateX, and we have two great speakers for our second session on citizen science and how it can impact our understanding of climate action. So we have Jeff Warren and Britta Voss. Hi, Jeff, and hi, Britta. And we can start with Jeff. Can you say a few things about yourself, where you're coming from, where you want to go?
Sure, big questions. Thanks for having me here. My formal background is actually I did undergraduate architecture, and then I was at the Media Lab in the Center for Civic Media. And I guess, I primarily come to this space as someone who makes things, works with my hands. I work with my hands a lot. I write code. I glue paper and wood together very well, my architecture background. And then, and I'm looking to where people from different backgrounds can find places to work together and solve problems, and sort of bridge communication gaps.
Excellent. You're going to have to teach us how to glue paper and wood together. I think that's going to be one of the follow-up courses. Yeah. Britta, do you want to say a couple things?
Sure. My background is in earth science. I went to the University of Washington and then the MIT Woods Hole Oceanographic Institution programs to learn about the chemistry of natural waters. And in my educational experiences, I became really interested in climate issues. And so I'm really excited in the idea of citizen science as a way to sort of bring the public more into the scientific process and connect scientists more with what society needs from science. And so I'm specifically, personally, I'm focused on river water chemistry, but I'm really interested to see what sort of things other people who use the ClimateX platform are interested in doing related to climate science.
Great. That's a great segue into, I think, what's a big question. One of the caricatures of citizen science is that it's really scientists making people do very trivial kind of tasks, right? Like identifying whether a galaxy is spiral or oval. And I mean, that's great, and you can get some training, but I feel that in the climate and maybe more expansively the environmental domain, citizens can contribute in a much more collaborative way. So if you guys have any thoughts on how that might be done, what's your big vision of citizen science or community science?
I mean, I guess I would say on sort of a more optimistic spin, I think, regular people care a lot about climate, and I think there's a great desire for regular people to have more information about climate science. And what individuals can contribute is something that science has a hard time doing, which is getting information from a wide variety of sources. And so hopefully people will see that as sort of an empowering opportunity for learning more about science and also contributing to it in a real substantive way.
Yeah, I echo that. Thanks. I think, I agree with you. Just the people have often been asked, like in Galaxy Zoo, to sort of like help do scientists' work for them, like be part of and I think there are positive sides to that. But I think as Britta points out, people have so much to offer, and especially in the environmental space, people are being directly impacted by problems, and so they have firsthand experiences that can really inform science, and they also, I think, come to the table sort of expecting there to be an exchange. They're not just there to hand over data or to process the data, but they're there to ask questions and in some ways tell scientists the questions that they need answered to address the problems they're facing.
I mean, that to me is really exciting because one of the big challenges in any kind of science, citizen or not, is what hypotheses to investigate and to test. And what you're saying is people who live and experience environmental challenges have a pretty direct view of what hypotheses might be worth investigating.
Yeah, and I mean, I guess the other, just to chip in another thought is, people also have these diverse skill sets. So scientists are very good at certain sorts of things, like, you know, formulating questions that are very answerable, like, you know, like hypotheses, you know, designing and running experiments, processing data, and so forth. But I think especially when you look at, say, the new maker movement and sort of people's ability to integrate ideas and technologies that are off the shelf, to recombine them and misuse them in creative ways, they really are ahead of formal science in some of the tools and some of the emerging technologies. And so I think that's sort of an interesting place where they could also bring something to the table.
Could you say a few words about how Public Lab is enabling that?
Yeah, sure. I think one thing that we do is we try to create a space between formal scientists and communities that need what science has to offer. And we try to celebrate the different things that each is bring to the table, and also acknowledge that each needs the other. And then to make a more discursive, a more public science, one that is more responsive to the needs of the public, but also one that is better informed and has better you know, resources at hand. You know, we need to break down some of the communication barriers between these groups. And we need both sides to sort of acknowledge that the other needs them and that they need the other, you know? So I think we try to help people build on each other's work, like get a scientist to clearly ask and acknowledge what they don't know something about, like their ignorance about the conditions at a local site that's polluted, and to ask for help. And on the converse side, get people to really try to structure very good, answerable questions about things they want to know about, and not just sort of completely open-ended questions, but questions that will help to refine a, you know, an inquisitive process that leads to answers, you know?
That's great. Britta, as a freshwater chemistry person, do you, like, if every human being on Earth was willing to be a partner in your experiment, what would you like? Is there something that you could do really fast that would not be possible as an individual scientist?
Yeah, I mean, there's so many things that individual scientists or even groups of scientists can't do, and I think you know, if everyone on Earth could either just fill a bottle of water or even just measure the water temperature in their river, there's so much monitoring work that just can't be done because of, you know, financial constraints, or there just aren't enough people out there making these measurements. And so citizens could do you know, a really valuable service to science by just going out and measuring their local rivers, because scientists can't be everywhere at once. And there's not a lot of support, especially from the federal agencies that fund a lot of science, for this long-term monitoring work, which is especially important for climate research. And so citizens could really do a lot to help create these long-term records that science really needs to see changes in the climate system.
That would be kind of fantastic, personally. I can almost imagine a kind of like you can ship bottles to people across the world and just ask them to ship it back to you.
Yeah.
Right? You know, go to your
river.
I
mean, I've been involved in sort of small scale versions of that, and I would do it myself. You know, I would go on vacation with a bottle of water, and I would bring back a sample, and maybe it wasn't something that we had an immediate question for, but we had the water and we could analyze it if we came up with a question.
Right. So I know that's happening a little bit in the microbiome world, right? So people are shipping microbiome samples to labs, and there's a more systematic process of collection. And I'm wondering, again, in a more collaborative fashion, is there a way to just build data collection and storage and analysis methods that are truly peer-driven rather than one way? What do you think, Jeff?
Well, a big, tough challenge. I guess in some ways, when I think about those questions, two sort of distinct, you know, lines of reasoning or lines of questioning come up in my mind. One is validation. So in community and in citizen science, people are often asking, well, how do we validate the data, given that it's collected by so many different people who may have seen different training or you know, whatever? How do we make sure that it's collected consistently? And then the other line is replication. how do we ensure that things can be replicated really consistently and rigorously? And actually, I think that on both counts, it kind of gets down to accessibility. And that's where I see the two connecting together, because when we talk about like open access, or we talk about reproducibility and good descriptions of methods, we're talking about like how easy it is to follow what someone has done. And in open access, we're often implying that this is only between scientists, that open access is from one scientist to another. But I think that it has broader ramifications, and I think that the public should be able to look at methods and understand them. They should be written in such a way that people can reproduce them. There may be cost barriers, there may be educational barriers. But when we talk about doing a large-scale water study, when we talk about doing large-scale collection and stuff like that, I think the validation issues can be met by some work on accessibility and good documentation.
Britta, any thoughts?
Yeah, I mean, there's definitely a push for that within the scientific community, and I think it's coming partially from the public, especially when it comes to federally funded science projects. There's a desire to have a lot of transparency. People can see the results and not just, give their tax dollars to these projects so they don't know what they're doing. And a lot of academic institutions and definitely the federal government are working to improve that transparency. So I think there's a lot of interests and desires that are coming together from both the public and within the scientific community.
Yeah, agreed. And it runs up and down the sort of, the stack, so to speak. I was actually just reading a regulation that the EPA, or a method that the EPA recognizes for assessing air quality plumes of emissions. And unfortunately, the method itself is, you have to pay for it. You have to buy a $64 PDF to read the method that the EPA recognizes. And I mean, that's almost beyond open access. I mean, that's a federally recognized method that you cannot know unless you buy the PDF. So obviously I think everyone has to sort of reassess where they fit into this feedback loop of information, but hopefully I think, as there's pressure to be open, the NIH, has an open access, requirement on some of their grants, or maybe all of their grants, and NSF has, I think, considered it, right? That would be really great, but, fingers crossed.
Yeah. I feel like there are some very deep issues here about both the sociology and the politics of environmental science and also design of experimental and other protocols so that they become accessible to people both in the way that they are communicated, but also the results and the outcomes. And I think there's an enormous amount of, exciting work to be done in building that pipeline, so that knowledge is really open.
It's true. I think it also has to do with how it's presented in a lot of ways. I think, for example, on the Public Lab site, we try to get people to document everything really well. And we've noticed one thing that's really interesting, which is when people write on a wiki page, they use the passive voice, and they use a sort of a scientific tone, but that doesn't necessarily reflect whether it's really rigorously written or whether it's well supported. It's sort of habitual to do so. And I think Wikipedia encourages that sort of neutral tone, as well as, of course, their neutral policy. But when people write in more of a blog format, we've noticed that they acknowledge what they don't know. They acknowledge that they are a person who's seeking information. They're better at acknowledging their sources rather than sort of declaring things to be the case. And so we've shifted in some ways to emphasizing, more of a blog style format, in addition to the fact that comes with a more discursive interaction. You can comment, you can call out and ask for clarification. So it's interesting to see how, something as simple as that sort of grammatic style that something is written in may actually have ramifications as to, rigor and citation and good documentation.
Yeah, I think that sort of issue, scientists talk about that with each other. And, if I pick up a paper from a different field and it's written not only with all of their jargon, but it's also written in the passive voice, it's just putting up a wall. And I think there's more and more people who are trying to move away from that. But this desire for more transparency is definitely helping to push people in that direction.
Yeah, and I think that some of it is demographic changes. I think younger scientists are probably more open to these new forms of expression. So I do feel that with ClimateX, we want to experiment with these new media forms, right? So not just in the pedagogical space, which is what the Hive is about, but also in data collection, in reporting, and in communication, because I think that all of those are crucial to building public, I mean, you know, we want to build a public concern and commitment to climate action. So I see no other way to do it than to do it with the public. Let's move on. What do you think? I mean, if you had to think of the $64 million citizen climate science question, what might that be? You know, it might not be the same for the two of you, but you know, off the top of your head.
Gosh, talk about big questions. I mean, I guess at Public Lab right now, you know, and I've hinted at a lot of this in sort of the responses I've given already, but we're really interested in people showing each other how to do things rather than sort of declaring that they have just done things themselves. And we're really interested in whether, when you ask someone to show someone else how to do something very specifically, in the sense of almost an instructable, if you're familiar with that site, can you get people to replicate, you know, and to post their replication and on a faster turnaround time than a peer-reviewed journal? Right. And can we not completely, like, you know, I don't think anyone wants to throw away the idea of peer review. You know, that's like the good part, I guess. You know, and just to say that you want to revise and you know, come up with a new format. You know, how do you take the best of what the scientific community has come up with in terms of publishing and sharing, and you know, mix it with some of these faster paced communication methods? I think that's a big question that we're trying to face.
It's a great question.
Yeah. Yeah, and I would almost kind of maybe even turn it around, like in terms of climate science, and especially what you said at the beginning about it being less led by scientists asking for help with their problem, asking what do citizens actually want? What are their climate questions? And then working with scientists to figure out how they can answer that. Like, you know, what are the regional climate impacts to the forest in New England, or, you know, sea level rise in the Southeast, and you know, bringing those two interests together.
Yeah, I mean, I really do think that there could be some fascinating studies done that way. And
yeah, which is totally not how science works at the moment, even citizen science.
Right, right. And I think Mara Freilich, who's done some work in Rhode Island, is one of the speakers, so we can talk to her a little bit about that too.
Yeah.
What I want to end with, we're going to bring you guys back for the Unhangout. And if you have some very specific, some challenge that people can take on in the breakout session in the Unhangout, something, a specific issue, question that you think people can address right away, that would be great, you know, in the maker kind of hands-on way.
Yeah, absolutely. I think I'm going to probably, by the time we actually do the Unhangout, have you know, more preparation and links to share. But there's a really interesting project called the Koki, named after a frog, a singing frog. But it's a very simple circuit that can be used to measure temperature or conductivity in water. And there's a set of interesting challenges on designing an experiment using this and plugging it in. And it's the kind of thing that we think that is simple enough people can do themselves. And maybe once we have the Unhangout, I'll elaborate on that challenge.
That would be fantastic. How about you? Concluding thoughts from you, Britta?
Nothing in particular.
Okay. We'll end with, is it Koki, is that right?
Mm-hmm.
All right, so we look forward to seeing the Koki circuit, and I think that will be, I mean, I think that's exactly the kind of thing that I like, the emphasis on making things. So it'll be a great on Hangout session where we can start discussing how to make climate action. So thank you very much, both Britta and Jeff. It was great, and we look forward to having you back on Hangout soon.
Yeah, thank you very much.
Thank you, Rajesh.
Bye.